Hello once more, and a warm welcome to Nestor's Bioacademy. If you can recall previously, we learned about diffusion, but today we are going to explore the physiological processes further and learn about another important process through which materials move in and out of the cells. And today we are going to talk about osmosis. So the main objectives of this lesson is that by the end of watching this video, you need to be able to define what osmosis is. You need to be able to describe the features of osmosis, and there's need for you to be able to describe the tonicity of solutions. So the key focus questions I need you to be able to answer at the end of this session are: one, what do you mean by osmosis? Number two, what are the key features of osmosis? We always refer to osmosis as a special type of diffusion. By the end of this session, I need you to be able to describe what makes it a special type of diffusion. What similarities does osmosis have with diffusion? And if there are notable differences, we need to be able to tell what differences are these. I also need you to be able to describe what hypotonic, hypertonic, and isotonic solutions are. As a requisite for this lesson, there's a need for you to be able to recall the cell membrane structure and especially its role, and particularly the role of semi-permeability. It is need for you to be able to recall what diffusion is. We discussed this in the previous video. In case you don't have a firm grasp of the concepts, you can consider reviewing that video before continuing with this. You need to be able to know what a solute is, what a solvent is, what a solution is, and what selective permeability refers to. If you can recall from your Form 1 chemistry, a solution is a mixture of a solute and a solvent. If I take a solute and I dissolve it in a solvent, I take sugar or I take salt and I dissolve the salt or the sugar in water, which is the solvent, I get a solution. And if I bring you over to this slide, I have two illustrations I want you to look at. I have solution A and solution B. Solution A is a concentrated solution, and solution B is a dilute solution. Looking at both cases, take note that being concentrated or being dilute does not refer to how much of the solution is in the beaker, but this is a measure of concentrations of the solutes within the solutions. So when a solution is said to be concentrated, the solution has got more solute concentration compared to another solution. A dilute solution, a solution is said to be dilute if it has less solute concentration. And these terms, concentrated and dilute, as we're going to use them largely in this session, we are going to use them comparatively. That is, this solution is concentrated, yes, but concentrated compared to which other solution, or this solution is dilute compared to which other solution. So these are terms we are going to use comparatively. That is like to mean, assuming I have two solutions. If I have solution A and solution B, and in both cases, let me say I'm having 100 milliliters of distilled water, but here I have dissolved 10 tablespoonfuls of sugar, but here I have dissolved 15 tablespoonfuls of sugar. So if I am to compare the two solutions, which one has got a greater concentration of solids? Obviously, it is B. So therefore, we say B is concentrated compared to A, and A is dilute compared to B. And if we are to separate two solutions of different concentrations, if you were to separate them with a semi-permeable membrane, what is it that is going to take place after some time? Like I want us to visualize this. I have two solutions here. Let me refer to this as A, then let me refer to this at the end as B. And in here, if you look at this plane carefully, there is a semi-permeable membrane separating them. And if we are to separate them, what is going to happen after some time? If you look at the same illustration after some time, you observe that there's been an increase in the level of solution A, but there has been a decrease in the level of solution B. And again, let us explore this further. Remember, we have a solution is made up of a solute and a solvent. So it means the change in the levels of these two solutions can only be brought about by movement of either two things, either the solute molecules or the solvent molecules. And if you look at this illustration carefully, you realize here, how many molecules of sugar can you see here? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. There's something interesting there. The amount of sugar molecules in A and the amount of sugar molecules in B, they remain the same even after some time, but the level of the solutions the levels have changed. So this can only refer to one thing. What is it that has moved? There has been movement of water molecules. And where have the water molecules moved from? The water molecules have moved from solution B to solution A. The water molecules have moved from the dilute solution to the concentrated sugar solution across this semi-permeable membrane. And that is what osmosis entails. So osmosis is simply the process by which water molecules move from their region of high concentration to their region of low concentration across a semi-permeable membrane. I repeat, the process by which water molecules, which are the solvent molecules, so it means you can talk of solvent instead of water, movement of water molecules from their region of high concentration to the region of low concentration across a semi-permeable membrane. You must always be very careful from defining osmosis in this way that I've highlighted in red, which says osmosis is the movement of water molecules from a region of high concentration to a region of low concentration across a semi-permeable membrane. This definition is what we will refer to as an ambiguous definition. And we say it's ambiguous definition because if you come back to this illustration we were talking about earlier, this is a concentrated solution. So you can refer to it as a region of high concentration because it has a high concentration of solute molecules. And this one is a region of low solute concentration. So it means when you are to define osmosis as movement of water molecules from a region of high concentration to a region of low concentration, it might bring in some ambiguity. And therefore, it's more accurate to refer to osmosis as a movement of water molecules from their region of high concentration to their region of low concentration across a semi-permeable membrane. And therefore, it usually means actually that when we come to comparing concentrations of solutions, a concentrated solution, while it has a high solute concentration, it usually has a low water concentration. While a dilute solution, even though it has a low solute concentration, it usually has a high water concentration. And that's why we talk of diffusion as we talk of osmosis as movement of water molecules from where the water molecules are highly concentrated, and that is, they are always highly concentrated in the dilute solution, to the region where they are at a low concentration, and that is in the concentrated solution, across this semi-permeable membrane. So osmosis can simply be defined as the process by which water molecules move from their region of high concentration to their region of low concentration across a semi-permeable membrane. You can also define osmosis as the process by which water molecules move from a dilute solution to a concentrated solution across a semi-permeable membrane. It still brings out the same meaning because in a dilute solution, the water molecules are at a higher concentration, and in a concentrated solution, the water molecules are always at a low concentration. And remember, osmosis has to be specified as a movement of water molecules from their region of high concentration to their region of low concentration across a semi-permeable membrane. If we are to illustrate this further again, you can observe this as the semi-permeable membrane. And the semi-permeable membrane, remember, it is going to prevent the movement of the solute molecules because the solute molecules are too large. They're not able to pass across the tiny pores of the semi-permeable membrane. But the solvent molecules, the water molecules, they're too small in size, so with them, they're able to pass across the semi-permeable membrane. So osmosis is always movement. And again, if you look at this illustration, you can see in the dilute solution, the distilled water in this case, we have a greater concentration of water molecules compared to the sugar solution, which is concentrated, which is the concentrated solution. We have got fewer water molecules. So the water molecules will be moving from this region where they are highly concentrated to the concentrated solution where they are lowly concentrated. And so, how are the water molecules moving? The water molecules are moving from where they are highly concentrated to where they are lowly concentrated. Pause a minute. Recall the definition of diffusion: movement of molecules from a region of high concentration to a region of low concentration. It therefore essentially means that osmosis is diffusion of water across a semi-permeable membrane. The water molecules are moving from where they are highly concentrated to where they are lowly concentrated across a semi-permeable membrane. And therefore, that is diffusion, because diffusion is movement of molecules from where the molecules are highly concentrated to where they are lowly concentrated. And therefore, there are two main aspects which makes osmosis a special type of diffusion. It is special in that it specifically involves diffusion or movement of water molecules from where the water molecules are highly concentrated to where the water molecules are lowly concentrated. And also additionally, unlike diffusion, osmosis categorically involves movement of the water molecules across semi-permeable membrane. So revisiting, strengthening or reinforcing our definition of osmosis, it is movement of water molecules from a dilute solution to a concentrated solution across a semi-permeable membrane. Or we can talk of it as movement of water molecules from where the water molecules are highly concentrated to where the water molecules are lowly concentrated across a semi-permeable membrane. Osmosis takes place around us. We encounter products or processes of osmosis in so many ways. The pure bottled drinking water is always made through the process of osmosis. Food preservation. Right now, many times you look at how we preserve food in our homes. And of course, we are having the refrigerators, we are having the deep freezers. But in the medieval times, before the advancement in technology, osmosis used to be applicable in food preservation, where we'll be using salts to applying salt around meat, forming a concentrated solution there. So water molecules will be drawn from the meat, and that will make the meat to be so dry. And when the meat is very dry, it becomes and favorable for the microorganisms which decompose food to thrive there. But nowadays, let's thank the advancement in technology. It is in very few areas where we still find food being preserved using those traditional means. And of course, osmosis plays a very critical role in water balance in our bodies, and the plants greatly depend on the process of osmosis for their survival. So as we have said earlier, what is it that makes osmosis a special type of diffusion? It involves movement of water molecules from their region of high concentration to their region of low concentration. And again, it involves movement across a semi-permeable membrane. And again, take note that just like diffusion, osmosis is also a passive process. It does not require energy for it to take place. All it requires is a difference in concentration of water molecules across a semi-permeable membrane, and osmosis will take place. We also need to proceed further and describe the tonicity of solutions. There are three terms we are going to encounter a lot when we are describing osmosis. These terms are hypertonic, hypotonic, and isotonic. So you need to be able to describe what you mean by these terms. These terms are basically comparative terms, which we always use to compare concentrations of solutions, concentration of one solution in reference to another. So we define a hypertonic solution as a solution with a higher solute concentration compared to another solution or compared to the cell contents. So if we look at these two illustrations, we have these two solutions we are having the concentrated sugar solution and the dilute sugar solution. Let's go back to the definition. A solution with a higher solute concentration compared to another. If you look at the two solutions, solution A has got a greater solute concentration compared to B. And therefore, we will say that solution A is hypertonic to B. Solution A is hypertonic to B. These are comparative terms, remember. If I am to, just like you'll use the terms, this is taller, this is shorter. But if I say taller, I must say it is taller than what? Taller than who? Shorter than what? So while the hypertonic solution has got fewer water molecule concentrations compared to the other solution. So it has got more solute, but less solvent molecules compared to the other solution we are comparing it to. And usually during osmosis, the hypertonic solution will always be the one that is gaining water. Let's remember, what was osmosis? It was movement of water molecules from a dilute solution to the concentrated solution. So a hypertonic solution actually is the solution that is comparatively concentrated in terms of solute concentration. Then we have hypotonic solution, just still on the same regard. Now, a hypotonic solution is a solution with a lower solute concentration compared to another solution or compared to the cell contents. Again, still coming to my A and B here. Which one has got a lower solute concentration? It is the dilute one, the dilute sugar solution. Therefore, this one is hypotonic to A. So we say that B is hypotonic to A. And therefore, a hypotonic solution is the solution that is comparatively dilute compared to another solution or compared to the cell contents. And even though it has got a lower solute concentration, it has a greater concentration of water molecules. So it is the one that loses water molecules during osmosis. Again, that is important to note. But when you have two solutions, which are of equal solute concentrations on either sides of the semi-permeable membrane. Those two solutions are said to be isotonic to each other. So when they are isotonic to each other, there will be no net osmosis because the amount of water molecules moving from one to the other will be the same as the one moving in the reverse direction. So if you are to separate them with a semi-permeable membrane, the levels of the two solutions will just remain the same. So when solutions are isotonic to each other, it means they have equal concentration of water molecules. So when they are separated by a semi-permeable membrane, there'll be no net osmosis taking place in either direction. So summarily, we have said osmosis is essentially like diffusion of water molecules across a semi-permeable membrane. And we are saying it involves movement of water molecules from a dilute solution to a concentrated solution across a semi-permeable membrane. It can also be said to involve movement of water molecules from a hypotonic solution to a hypertonic solution across a semi-permeable membrane. And the key takeaway I need you to have from this session is the definition of osmosis. You need to have a firm grasp of that. And remember, avoid defining osmosis ambiguously. Like in the first illustration that I gave, do not say osmosis is movement of water molecules from a region of high concentration to a region of low concentration across a semi-permeable membrane, because we will not be sure, like, what are you referring to? Are you referring to a region of high concentration in terms of solute concentration, or high concentration in terms of solvent concentration? So it's crucial for you to understand that you need to avoid that ambiguity by defining osmosis using either of the following statements. It is the movement of water molecules from a dilute solution to a concentrated solution across a semi-permeable membrane. It is the movement of water molecules from where they are highly concentrated to where they are lowly concentrated across a semi-permeable membrane. Either of those two statements will always work for you very accurately. So thank you so much for checking in, and till the next video, take good care.